I know on the front page of these notes, sum and difference notes, that we work with degrees, but we're going to switch over to radians. It's a little bit easier, maybe only for me, but I want to take a look here because oftentimes the problems, these sum and difference problems, are expressed in terms of radians. And if you watch the front side of the video, the front side of the notes, the nice part about these is that you might pick two angles and your next door neighbor picks two different angles, but it still works out the same way. The difference here that we see on these particular problems here at the top of the page is it says find two angles on the unit circle measured in radians that either add or subtract to give you the following. Try to come up with multiple pairs of angles that work. Well, I'm going to stick with one or two pairs of angles here, but remember, these angles need to link back to angles that we know from the unit circle. So the first thing that I think of here is that 5 pi is 2 pi over 12 plus 3 pi over 12. Remember, when we add fractions, we need to have a common denominator, and we do, but does that work? And the thing is, you can experiment around with it. Sometimes we don't get it right on the first time, but 2 pi over 12 is the same thing as pi over 6, and 3 pi over 12 is the same thing as pi over 4. So that one works out pretty well. You can't do 4 pi over 12 plus 1 pi over 12 because we don't have any values where we know 1 pi over 12. But when we look at the next one here, and I know I only did one on that one, but we could do something like, I picked the biggest value that I could practically on the unit circle. I picked 11 pi over 12 plus 12 pi over 12, because 11 plus 12 is 23. So we know what 11 pi over 12 is, and 12 pi over 12 is 1 pi. We know values. They link back to the unit circle, so we know that. You could pick another set. I still picked up fairly, I mean, they're not big, fractions are not big, but 9 pi over 12 is another angle that I use, plus 14 pi over 12. Again, 9 plus 14 is 23. And when you look at this and you simplify this fraction, 9/12 is 3 pi over 4, and 14 pi over 12 is 7 pi over 6. And again, both of those values are on the unit circle. So letter C is 1 pi over 12. And a couple of choices here. I started with 3 pi over 12 minus 2 pi over 12. Again, we want to make sure that these angles link back, but 3 pi over 12 we've already seen is pi over 4, and 2 pi over 12 is pi over 6. And we know what pi over 4 is from the unit circle. We know what pi over 6 is from the unit circle. And to do 4 pi over 12 minus 3 pi over 12, and again, 4 pi over 12 is pi over 3, and 3 pi over 12 is pi over 4. So all of those combine, or they link back to the unit circle, and we can use them when we're applying the sum and difference identities to find our values. Like what we're going to do down here in the examples. I'm going to start with the cosine of 5 pi over 12. And remember what the first step is. The first step is to write down what the formula is. And in fact, what I look at here is we just did 5 pi over 12. So I'm going to use those values of 2 pi over 12 plus 3 pi over 12. And maybe you don't write that step down, but when we simplify those values, as we saw, it's going to be the cosine of pi over 6 plus pi over 4. So we know those values in the unit circle, and we can go back and we can write down our formula, and we are adding these together. So I just want to point out that when we add these together, the plus is on the top of the plus minus. So over here, when we're applying the formula, we're going to use the minus. So this is going to become cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. So we identify the values, we've come up with the formula that we're going to use, and now we're going to evaluate before we simplify. And the cosine of pi over 6 is the square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. Sine of pi over 4 is the square root of 2 over 2. And when we simplify, remember when you're multiplying fractions, you're going to multiply the tops of the fraction, also known as the numerator, the bottom of the fraction, also known as the denominator. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Over here, 1 times square root of 2 is square root of 2. 2 times 2 is 4. So when we finish this problem, because we have a common denominator already, we can just write our answer as the square root of 6 minus the square root of 2 all over 4.